Welcome to Swayam MOOC course, NGOs and Sustainable Development, Unit 3, Module 20, Non-Renewable Sources of Energy and its Effect. Learning Objectives. By the end of this module, you will be able to learn about the various types of non-renewable energy sources, understand the advantages and disadvantages of each, discern the necessity to use renewable sources of energy in the place of non-renewable energy sources for sustainable development. Now, what is non-renewable energy resource? Natural resources that are found underground are referred to as non-renewable energy resources. These are non-renewable, finite energy sources, which implies that once they are used, they are gone forever. The development of the resources often takes millions of years. The two major non-renewable resources are fossil fuels, which includes coal, oil, natural gas, and the other one is nuclear power, which is obtained from uranium ore. The non-renewable energy sources are extracted in the form of solids, liquids, and gas, which are subsequently transformed for consumption. If we take the solid, it is coal. The composition includes carbon, hydrogen, nitrogen, sulfur, oxygen, and minerals. The oil form is petroleum, and the composition includes carbon, hydrogen, again nitrogen, sulfur, oxygen, and minerals. And the gas is natural gas, which has all the others except minerals. Now, what are the characteristics of these fossil fuels? Due to their limited availability, they are also known as the stock resources. After recycling, these compounds can be again used. Minerals which are often present in both coal and petroleum in the lithosphere of the earth in various forms are the source for the non-renewable energy. The non-renewable energy sources can be found in gas, solid, liquid form in all the three states of matter. Non-renewable energy resource includes coal, ignitable materials, petroleum, and natural gas. Now let us see fossil fuel, coal. The use of coal as an energy source has a long history. The Chinese have mined and exploited coal as a fuel since 10,000 BC. They also used it for smelting of ores. This resource was also used in several parts of the world during the Bronze Age between 2000 and 1000 BC. In most recent times, coal still provided 25% of the world's primary energy supply, ranking behind oil, which was 35%, and ahead of natural gas, 21%. Because the reserves of coal are large compared to those of oil and natural gas, coal was an important energy source for the common man. About 300 million years ago, plant debris that flourished in freshwater wetlands gave rise to coal. Now let us see how this plant and animals get transformed to coal. Peat, also known as peat bog, was created as a result of the accumulation of dead plant matter. Since the plant matter piled below the water, the lack of oxygen in the wetlands prevented the decomposition. Many peat sites are submerged inside the oceans, and the peat was then covered with sea sediments. The nature of peat bog progressively altered due to the weight of these sediments which was above it, and slowly over the years, millions of years, coal was created. Even though peat is a low-grade fuel because of its high water content, it is nonetheless very useful as a fuel today. After being pushed down by silt over many centuries, peat eventually turns into coal. It first transforms into lignite, which is a low-grade coal, which is also known as the brown coal. Rock, that is dark or brownish, is coal. Coal is burnt to produce energy. The transformation of ancient life into coal is known as carbonization. 3 meters of dense vegetation is required, and when this 3 meters of dense vegetation is crushed to 1 foot, then we have coal. So we need 3 meters of vegetation for over millions of years, which gets transformed into just 1 foot of coal. So that is the extent, the number of years required to form coal. The lowest grade of coal is peat. Depending on how much of carbonization that has happened, coal is rated. Now when we look at this figure, we find how the coal is formed. As the heat is and the carbon content increases, peat slowly gets transformed into coal. When the moisture level is higher, then peat is found. So peat is actually not coal. It is partially decayed plant matter that is there in swamps and bogs, and it has a low heat content. When there is enormous amount of heat and pressure exerted on this plant over millions of years, slowly we find lignite is formed, which is known as the brown coal. The heat content in lignite is very low. We have heard about the Neyveli Lignite Corporation. So there it is the lignite that is found at Neyveli, and it has low heat content, low sulfur content. Lignite is available in only certain areas. Then comes bituminous, which we call as the soft coal. Bituminous is the time when is the period between lignite and hard coal. So bituminous is a soft coal which is extensively used as a coal because of its high heat content, and enormous supply is available across the globe. It also has a high sulfur content. After many years of heat and pressure underneath the earth, then we have anthracite, which is the hard coal. And hard coal is a highly desirable fuel because of its high heat content and low sulfur content. Supplies are, however, very limited, and it is available only in very rare areas. Now let us see the classification of coal in detail. Lignite or brown coal is a non-agglomerating coal with a gross calorific value of 17.4 megajoules per kg. That is the heat content available, and it has a volatile matter larger than 31% of its weight. Today, lignite has a gross calorific value between 5.5 to 14.3 megajoules per kg. Now when we come to subbituminous coal, is a non-agglomerating coal with a gross calorific value larger than 14.3 megajoules per kg but smaller than 17.3 megajoules per kg, and the volatile matter is larger than 31% by weight. When we come to the bituminous coal and anthracite, they are non-agglomerating coals with a gross calorific value larger than 17.4 megajoules per kg. So the heat content that is present in anthracite is very high. Coal can be mined in two ways. Either it can be underground mining or surface mining. When coal is found beneath the earth's surface, often 300 meters or 1000 feet below the earth's surface, then it is deeper than majority of the Great Lakes, underground mining is employed. So as the animation indicates, the underground mines is like a tunnel where even vehicles pass through these tunnels, and the coal that is taken out mined from these underground mines are transported using the lorries, the vehicles that goes inside these mines, and then they are brought out to the surface through elevators. When coal is found relatively close to the earth's surface, then it is called surface mining. Companies must first remove the region in order to get the coal. The soil and trees are removed, then it will be simpler to get the coal from the earth. This process results in the destruction of the natural habitat in and around that area. Now these are the different layers that is found when coal mining is done. When it is underground mining, we have elevators that goes deep down into the earth's surface. As already mentioned, 1000 feet below the earth's surface, the elevator has to enter, and tunnels are formed to mine the coal. Of course, the natural habitat in the region is not spoiled to that extent as compared to surface mining. So when it is surface mining, then the habitat is lost because the area is cleared for doing surface mining. So the different types could be mountaintop mine, contour mine, high wall or agar mine, or area mine. So these are the different types of surface mining methods. Coal supplies around half of the country's electricity. Our lights, refrigerators, dishwashers, and majority of the plugged-in devices are all powered by electricity, which comes from coal. Burning coal produces byproducts that are also worthwhile. The leftovers are used to create a variety of products, including cement, polymers, and also roadways. Now, the uses of coal, we find that 68% of the use is used for electricity generation, and some portion, 18%, is for general other purposes like for refineries, for paper manufacturing, for chemicals, for pharmaceuticals. 7% is used for steel production, 4% for cement production, and 3% of coal is used for heating purposes. However, coal is a very dependable form of energy. We can count on it to supply fuel and electricity day and night, in the summer or in the winter, whether there is sunlight or whether there is rain. So, coal is a very dependable fuel. However, it does have its own advantages and disadvantages. Advantages are coal is cheaper than other fossil fuels. It is easy to store. It has an ability to convert into different forms of energy. There is minimum waste produced. It creates a lot of employment for people. It is highly compatible. There is minimal room for wastage. It is a safe alternate. It has a simple burning process and it is easy to mitigate risks. Now, there are so many advantages. Now, let us see at the disadvantages and why we say fossil fuels is not an environmentally friendly fuel. Disadvantages: it is non-renewable. The coal that has been formed over millions of years, we are taking it to produce electricity. So once we use the coal, we are not going to get back the coal. So it is non-renewable. It is harmful to health. It causes noise pollution. It is harmful to the natural habitat and to the environment. It creates a high level of radiation. There are high carbon emissions and it is a deadly energy source. It displaces human settlements. But still, with all these disadvantages, we continue to use coal to produce electricity and we use that electricity for all our appliances, be it at home or in the industry. The problems are the coal life cycle. It consists of air pollution and toxic waste. Coal power plant generates waste. Transportation generates pollution. There is coal washing, coal mine waste and coal mining. All the life cycle of coal, at all stages, there is generation of pollution which is not environmentally friendly. Mining operations, which involves digging, blasting and removing rocks and soil that are on the top of the coal seam, seriously impact the air quality and the noise level. In areas where there are aquifers, which is situated close to the river or the water beds, surface mining causes erosion, causes pollution, and the water gets contaminated. During or after mining operations, the underground mining may collapse and the land subsidence may take place in the mining sites. At work, coal miners risk the cave-ins that could occur or sometimes explosion, because the miners are working inside the coal mines, which is the tunnels, and sometimes the coal or the cave-in may happen in the coal mines. So again, that's a serious threat to human life. In addition, there are poisonous dust that is emanating when coal is getting mined. So in addition to all these issues, the main cause of air pollution is the burning of the coal in the thermal power plant where there is production of electricity. So that's the place where there is enormous amount of air pollution that happens, which is harmful to the environment. It leads to climate change and several health hazards. Now coming to the second fossil fuel, which is petroleum, or in other words, oil. Only one non-renewable energy source, which is crude oil or petroleum oil, is available in the liquid form. Plants and animals again die and sink to the bottom of the sea. The plant and animal layer gets covered with mud. These remains were submerged under the mud and rock for over millions of years, similar to coal. Over time, more sediment creates pressure, compressing the dead plants and animals into oil. It is extracted by drilling a vertical well into the ground or the ocean floor, and it is discovered between the layers of earth crust and or between the rocks. Now, as the picture indicates, small marine organisms, plants, get submerged. After they are dead, they get submerged into the ocean bed. And after millions of years, 300 to 400 millions of years, these get sedimented, these gets frozen under the rocks, under the sediments, and slowly over a period of time, this organism turns into oil and natural gas. And once these are converted to oil and natural gas, by drilling, this gas and oil can be tapped from the surface and can be extracted for electricity or other purposes. Oil literally bubbles out of the ground in some locations. For example, in Los Angeles, California, at the La Brea tar pit, large pools of heavy oil are bubbling up through the soil. To reach the oil, we need to drill into the ground. Deposits can be found both on and beneath the ocean surface. Oil corporations can extract petroleum 365 days all through the year, 24 hours a day, using a drill rig, and drilling can be done. Companies dig offshore when oil is found beneath the ocean floor. They need to construct an oil platform. Some of the largest man-made buildings are the oil platforms which are found in the oceans, which are known as the offshore dig drills. Oil needs to be refined after it has been drilled. Petroleum, often known as crude oil, is a thick, dark liquid which is made up of flammable hydrocarbons and has traces of oxygen, nitrogen, and sulfur. The current oil reserves may not endure through the middle of the 21st century, according to scientists, because they feel it will get depleted shortly during this century itself, and more than the new oil fields are found. Now, typically deposits of crude oil and natural gas are sealed beneath the ocean floor or the crust of the earth on land. Following extraction, the crude oil is moved by pipelines, trucks, or ships to a refinery. Different types of products that we get from oil is possible through fractional distillation of the crude oil. Oil is heated and distilled in refineries to separate it into various components with various boiling points. So as shown in the picture, we get gasoline around 25 to 60 degrees, we get petroleum gas at 25 degrees, we get naphtha between 60 to 180 degrees, paraffin between 180 to 220 degrees, diesel between 220 to 250 degrees, fuel oil which can be used in ships between 250 to 300 degrees. Lubricating oil is a little denser. As we come down in the picture, we get liquid a little denser. So lubricating oil, which is a dense liquid, we get it at around 300 to 350 degrees. So the crude oil helps us to get all these different types of products, byproducts, through fractional distillation. The lowest level is the bitumen. Also tar is obtained, which is the waste out of the fractional distillation. Again, tar is also used for laying the roads. Gases and gasoline, aviation fuel, kerosene, diesel, oil, naphtha, grease, wax, asphalt are the key ingredients which we obtain from fractional distillation. Petrochemicals are some of the byproducts of oil distillation and are used as raw materials to create products including insecticides, plastics, synthetic textiles, paints, and pharmaceuticals. It is also used to produce plastics, heating oil, propane, jet fuel, artificial food flavors in addition to gasoline and diesel. And these are also used to power automobiles. So some of the petroleum products which are used is given in the animation. The remainder can be processed and used in solid products like water pipes, shoes, roofing, vitamin capsules, and thousands of other things. And the oil byproducts are also used for nail polish, etc. So oil has got its own advantages and disadvantages. So the cost of extracting is not very expensive considering the huge amount of oil that we get and the usage of the oil products. It is also a trustworthy and a consistent source of income and energy. It is a readily available energy source that enables us to travel by car in the form of petrol or diesel or natural gas. Numerous goods on which we rely contain petroleum as an ingredient. Of course, it has its own disadvantages. The ecology is harmed when gasoline is used. We breathe in the dangerous fumes and gases that are released. More so, the fumes that come out of our vehicles has got very hazardous health impacts. A spill of oil is another possibility. The oil in the well may erupt and spill onto the water or nearby land if there is a problem with the drilling equipment. Environmental catastrophes are caused by oil spills, particularly offshore accidents. Oil floats on water, making it very difficult for the aquatic life, the fish, to survive, and it damages the aquatic life by the oil that is spreading over the ocean floor. Now coming to the third type of fossil fuel, which is natural gas. Natural gas is a gaseous, non-renewable resource that can be discovered underground close to the crude oil reserves. Natural gas, which mainly consists of methane, is frequently found above the crude oil deposits. Methane makes up majority of the natural gas. Also, it can include other types of natural gas such as propane, ethane and butane. Additionally, it has trace levels of highly poisonous hydrogen sulfide as well as heavier gaseous hydrocarbons. Natural gas is present underground in quantities that are measured in cubic meters. Deposits of natural gas can be found a few hundred meters under the ground. Companies can drill straight into the ground to extract the natural gas. In rock formations, they can extend maybe up to some kilometers wherein the natural gas is trapped. Some businesses utilize a technique known as hydraulic fractioning or fracking to extract the natural gas. The term hydraulic or fracturing both refer to the use of water as a mechanism to draw out the gas. In this method, the subterranean rock are torn apart using high pressure water. The stored natural gas will then be released from the rock formations. They can inject acid down the well to disintegrate the rock if it is very hard to break. To prop often the rock and allow the gas to escape, sometimes they use small minuscule amount of sand particles or glass particles also to break the rock. Now, forms of natural gas. There are two forms of natural gas. One is compressed natural gas, or commonly known as the CNG. So, compressed natural gas is produced by compressing natural gas to less than 1% of its volume at standard atmospheric pressure. To provide adequate driving range, CNG is stored on board a vehicle in compressed gaseous state at a pressure of about 3,600 pounds per square inch. Liquefied natural gas, or LNG, is natural gas in liquid form. LNG is produced by purifying the natural gas and supercooling it to minus 260 degrees Fahrenheit to turn it into liquid. During the process, which is known as liquefaction, natural gas is cooled below its boiling point, removing most of the extraneous compounds found in the fuel. The remaining natural gas is primarily methane with small amounts of hydrocarbons. Now, there are advantages as in all other types of fossil fuels, and there are disadvantages. Now, when we look at the advantages, compared to other fossil fuels, oil and coal, natural gas is affordable to extract. Only carbon dioxide and water vapor is present, which if we exhale is not very harmful. Rather than burning coal, this is more healthier. However, now looking at the various problems associated with oil and natural gas, oil and gas leaks are a very important problem which we need to address. The oil leaks causes harmful, if it gets into the drinking water, it is very harmful for humans also, in addition to aquatic life. Explosions may be caused by natural gas leaks from pipelines, storage tanks and distribution tanks. Natural gas contains a significant amount of methane, a greenhouse gas whose leakage contributes to global warming. However, it is considered a clean fuel compared to coal and oil. Subsidence or land sinking may also result because of the extraction of oil and gas, similar to coal. Just like in coal mines, subsidence could happen, so also in oil and gas mining, land subsidence could occur. For instance, the extensive oil extraction that began in 1928 in the Long Beach Harbor neighborhood in Los Angeles, USA, resulted in considerable ground subsidence. The ground descended around 9 meters over the well location. There was a need for flood control measures along the shoreline due to the extensive subsidence. The cost of damage to roads, buildings, and other facilities are estimated to be $100 million. Brine was previously a significant issue with onshore oil wells. 10 barrels of brine are typically extracted for every barrel of oil produced. Early on, the brine was merely dumped into the ground or into the adjacent waterways. Most brine today are injected back into the well. However, if the casing lining the well is broken or rusted, brine can contaminate the fresh water and may get into the aquifers, which is used for drinking water purposes. In addition to these issues, oil pollutes the ocean. Natural seepage from the offshore deposits accounts for around half of the oil that gets into the ocean floor. Annually, approximately 600 metric tons of oil is found to seep into the ocean, destroying aquatic life. Oil well blowouts, pipeline breaches, tankers, and pipeline leaks account for 20% of the oil that pollutes the ocean. The remaining oil is released inland and is transported into the ocean by rivers. In addition to routine operations, oil delivery to the coast also causes leakages from offshore wells. Both freshwater and marine habitats are impacted negatively by oil contamination. Aquatic plant and animals perish. It could take the organisms 2 to 10 years to come back to its original state. Air pollution is also brought on by burning oil and gas. Environmental issues may arise during the natural gas extraction. Mini earthquakes can also be produced because of the rock fracture which is carried out to get the gas that is trapped in the rock. Other water sources may also get contaminated by the high pressure water and chemicals that are injected underground during the extraction of gas. Drinking water sources may become contaminated and dangerous because of water from manufacturing plants, runoffs from agricultural pesticides, gasoline leaks, animal waste, dead animals, drugs flushed into the water supply, seepage, and waste runoff. So in addition to all this, the drinking water also gets contaminated from the extraction that is happening underground. Next, coming to the fourth type of fossil fuel, which is nuclear energy, which is obtained from the uranium ore. Nuclear fuels make up for the second category of the non-renewable resources after fossil fuels. Another non-renewable energy source that is frequently mentioned is nuclear energy. Although the material utilized in the nuclear power plants is not renewable energy source, however, nuclear energy is renewable. It is mostly obtained by mining and refining uranium ore, a radioactive element that exists naturally underneath the surface of the plant. Some or small amounts of uranium are present, and miners frequently collect these deposits for further processing and purification. Nuclear fusion, a process that the mineral uses to produce energy, produces enough pressure to drive turbines and hence produce nuclear power. Atomic nucleus energy is referred to nuclear energy. High-tech techniques are utilized to produce nuclear energy from radioactive materials. Around the world, generating power via nuclear energy has now become very common. The potent energy contained in an atom's nucleus or the core is harvested through nuclear energy. Nuclear fission is the splitting of an atom's nucleus, and this is the process that releases nuclear energy. As shown in the picture, It shows a nuclear power plant. Nuclear power plants are sophisticated devices that have the ability to control nuclear fission and generate electricity. The element, which is uranium, is one of the most frequently used source of energy in nuclear power reactors. Despite the fact that uranium may be found in rocks all over the world, nuclear power plants typically use uranium-235, which is a highly uncommon form of uranium. It is a non-renewable resource. It is possible to get energy from radioactive materials using both nuclear fission and nuclear fusion. Now, in nuclear fission, this process occurs when heavy atom nucleus such as uranium U-235 or plutonium P-239 splits into smaller particles, releasing tremendous amount of energy. As shown in the picture, the neutron gets broken in uranium-235, or it could be plutonium, and it releases energy which is broken into lighter elements. This energy, which is a tremendous amount of energy, drives the turbine. Krypton and barium are created, energy is released, and numerous neutrons are released each time a neutron interacts with the nucleus of uranium-235. These fresh neutrons could again interact with additional U-235 atoms and start a chain reaction. When this nuclear breakdown occurs, neutrons and other nuclear particles escape from the nucleus. The neutron may lead to the splitting of other atomic nuclei, releasing additional neutrons as well as energy. Once it has started, this chain reaction will not stop. It keeps releasing energy until the fuel is used up or the neutrons are kept from colliding with other atomic structures. The nuclear chain reaction is regulated in the reactor in a nuclear power plant. The heat produced is utilized to create high pressure stream which spins the turbines, which in turn provides electricity. Here, heat is dissipated by a water coolant and transferred to water in a steam generating unit via a heat exchanger. The steam generated drives the turbine, which generates electricity. After the steam has passed through the turbine, it is condensed using cooling water. Next, coming to the second type, which is nuclear fusion. So how does nuclear fusion work? The hydrogen atoms are heated and fusion reaction takes place. Fusion is joining together. Just like fission is breaking away, fusion is joining. So here, deuterium and tritium are joining together, and that ends up with helium, releasing the neutron. And again, enormous amount of energy is released, which is used to heat the water and to generate steam. In this process, lighter nuclei such as those of hydrogen isotopes, deuterium and tritium, combine to generate smaller, heavier nuclei, releasing enormous amount of energy. Two other nuclear technologies for producing energy from nuclear fuel in a safe and cost-effective manner have also been proposed. They are the nuclear breeder reactors and fusion reactors. Now it has got its own advantages. As all of us know, nuclear resource is a very good energy source. But if there are accidents, care has to be taken because thousands of people get affected. First, let us see the advantages. The benefit of employing nuclear energy instead of coal and oil for energy production is that it pollutes relatively less compared to oil and coal. Due to the highly concentrated source of energy in nuclear fuel, less strip mining is necessary. Additionally, transporting nuclear fuels is far less expensive than transporting coal or oil to produce the same quantity of energy. No greenhouse gas or air pollution are produced by nuclear power facilities. They don't harm the surrounding environment, and it can be developing the urban and the rural areas. However, it has got its disadvantage where care has to be taken. Harvesting nuclear energy is challenging. Construction and operation of a nuclear power plant is exceedingly challenging. Many communities lack the engineers and scientists to create a secure nuclear energy power plant. Radioactive material is also created by nuclear energy, and radioactive wastes are very harmful to humans. An alternate to fossil fuel for energy production is the radioactive materials. radioactive ore is only available in finite amount in supply. On the other hand, a tiny amount of radioactive materials can produce a lot of energy. However, extremely toxic radioactive waste can result in burns, increase in skin cancer, blood disorders, bone degeneration, among several other health hazards. It could cause skin diseases, also damage the reproductive organs in human beings. It can cause abnormality in bone marrow, destroys the retina of eyes. So the toxic radioactive waste that comes out of nuclear energy has to be stored in a very careful location which is not used for several years. Radioactive pollution results from improper disposal of this radioactive waste. However, the disposal of nuclear waste, environmental contamination with long-lasting radioactive materials, thermal pollution, health effects from exposure to low levels of radiation, limited supply of uranium ore, high construction and maintenance costs, disputed reactor safety, human or technical error that could result in major nuclear accidents are some of the major disadvantages in going in for nuclear energy use. Problems with decommissioning nuclear plants when they are 30 to 40-year-old is a challenge. There are a number of crucial questions regarding the production of nuclear energy that has still not solved. Nuclear power plant safety has come under scrutiny under the 3 Mile Island plant accident in USA as well as the Chernobyl tragedy that happened in USSR. Now let us look at the advantages of non-renewable energy at the overall level. Energy content of the non-renewable energy materials is very high. Compared to renewable sources like solar, wind, resources like coal and oil generally give us more energy and it is readily available at the outlets. Coal mining, oil sales and the building of pipelines and for natural gas can all result in enormous costs. In a home or somewhere else, these resources are very simple to use since it is available in pipelines and readily available at the point of switch. Non-renewable energy sources are available to consumers at a very reasonable cost because of its massive usage. Some people, conventional energy sources like coal and oil cannot be replaced by new technology, so they do not want to go for an alternate fuel. It is simple to locate a non-renewable energy everywhere. This suggests that they can be easily transported across the globe. Non-renewable energy is a resource that can be used by people who are also living in remote areas. The most significant benefit of non-renewable resources is the massive job creation. If it is going to be coal mining, oil mining, the enormous amount of job creation for that locality. The processes involved in extracting, moving, refining requires people. The majority of the non-renewable resources are also easy to store. Now coming to the disadvantages of these non-renewable energy. The time-consuming nature of the non-renewable energy is one of the major drawbacks. If it is coal or oil, it has taken millions of years to get this energy, to get the form of coal or the form of energy or the gas. Non-renewable energy source, as the name occurs, is not renewable in nature and requires billions of years to get formed. Usage causes the disappearance of this energy source. It could be selfish to use the non-renewable energy source carelessly without considering the needs of the future generation. Because non-renewable energy sources like fossil fuels release chemicals like carbon monoxide, they are very harmful and may cause respiratory diseases in people. A number of health concerns are more likely to affect people who work in coal mines and in oil drilling. When burned, energy sources like coal, oil generate a lot of carbon dioxide, which leads to climate change and global warming. Oxides such as sulfur oxides and others created by the combustion of fossil fuels may lead to acid rain, which harms human as well as wildlife. A lot of non-renewable energy sources emit pollution which surround all the structures. People primarily complain in modern cities of smog, of dust, and not a clean environment to breathe in. Transporting non-renewable resources can occasionally be dangerous since large cargo ships and oil tankers may sometimes collide, which spills all the contents of the energy, be it oil, into the ocean, and this causes a lot of risk in terms of aquatic life dying. We always need a significant amount of fuel in reserve to keep the power plant running. So this could cost a lot of money and takes up a lot of room. Now let us see the global impact of using non-renewable energy. It is well known that burning fossil fuel harms the environment and is a contributing factor to global warming and climate change. Nuclear materials also carry concerns because of their toxicity and because of their radioactive nature. Fossil fuels have negative economic effects in addition to environmental ones. The supply and demand of these resources are constantly disputed. The cost of obtaining these energies is steadily rising, and both suppliers and customers struggle to deliver and make use of these resources optimally. Consumers are eventually no longer able to purchase the product because of the escalating costs. Petrol prices always seems to be increasing, and as vehicles increase, petrol prices are also found to increase. Now let us see the environmental impact of the non-renewable energies. These resources which are found in nature are getting diminished, are vanishing as we start consuming. Oil reserves will run out by 2043 according to a recent study that was published in a scientific magazine Nature. The same is true for coal and natural gas. There will be a time when we won't have access to any fossil fuels. But it's not because of that these resources are depleting that we need to look at other energy sources, but it is also because of the negative influence it is having on the environment. When we look at the climate change, carbon dioxide up to 1950 had a steady increase, almost a constant increase. But since 1950, after the Industrial Revolution, we find the emission of carbon dioxide has increased exponentially. The oil slicks and oil spills are a very dangerous hazard to the environment. The radioactive waste, if there is going to be a leakage in the radioactive waste, we cannot imagine the number of lives that will be lost. Acid rain, which is going to destroy the habitat, the plant habitat, animal habitat, and the humans, the effect on human health. So all these are the effects of using non-renewable energy. Of course, usage of non-renewable energy has its own advantages, but to improve the world for the coming generation, to give a better world, for a greener world for the future generation, it is crucial to take up appropriate steps to regulate the use of non-renewable energy sources. Now let us see a few questions and answers in this module. Why is fossil fuels bad for our environment? Air pollution from fossil fuels can cause acid rain, eutrophication, which is excessive nutrients that can harm the aquatic ecosystem by lowering the oxygen level, damage to the crops and forests, harm to wildlife. All these are from the air pollution point of view. In addition, water pollution because of oil spills, fracking of rocks to get gases, fossil fuel which causes water pollution. So all these are the detrimental effects to the environment, the reason why we should not use non-renewable energy sources. How long before we run out of fossil fuels? Because it is non-renewable in nature, there is going to be a time when we are not going to have these fossil fuels. It is predicted that we will run out of fossil fuels during this century itself. Oil is expected to last only up to 50 years, natural gas only up to 53 years, and coal up to 114 years. Yet, renewable energy is still not very popular enough, and it is essential that we take up the usage of renewable energy to compensate for the non-renewable energy which is depleting and is disappearing from the planet. Question 3. How do fossil fuels affect human health? Yes, all along we have seen how it has damaged the climate. The release of pollutants has caused deadly effects on the planet, has caused deadly effects on the human health such as strokes, disorders, asthma, several other health disorders. It has also been linked to autism disorder, Alzheimer's diseases, etc. So it is high time that we start thinking of switching over from non-renewable energy sources wherever possible to renewable sources of energy. So in this module, we have learnt about the various types of non-renewable energy sources, understood the advantages and disadvantages of each of them, discerned the necessity for using renewable energy sources in the place of non-renewable energy sources for achieving sustainable development. Thank you.